Welcome to Infectious Disease Lesson 2.3, How do Infectious Diseases Spread? The goals of this lesson are to experience the difficulty of identifying an infectious agent and its source, and demonstrate that vaccines protect individuals and prevent the spread of disease. At the end of the lesson, the students should be able to explain the process by which a disease spreads, and explain the effects of vaccination on the spread of disease. We will achieve these goals by taking part in a disease spread simulation activity to map the course of an infection and identify its source, engaging in a Socratic discussion about vaccination, and extending the activity by performing calculations to further understand the impacts of vaccination. To prepare for this lesson, you'll need to review the following key scientific concepts. Transmission patterns can be used to identify the source of an infectious disease. Vaccination disrupts transmission, protecting both vaccinated and unvaccinated people. And you'll want to review Koch's postulates: association, isolation, causation, and re-isolation. You can review this scientific content in the background reading provided for you in the teacher primer, the teacher manual, and the student workbook. The teacher primer provides in-depth knowledge about the scientific content presented in this lesson. The teacher manual or lesson plan provides a minute-by-minute explanation of the lesson structure, and the student workbook provides additional explanation for students. Note that an annotated version is also available for teachers. Be sure to print the lesson worksheet. This lesson also requires the assembling and testing of materials for the spread simulation. The instructions for the simulation are in the teacher prep for the infectious disease simulation document in the Lesson 2.3 curriculum materials. We recommend using starch and iodine as indicators for the simulation. This includes boiled starch, iodine as indicator, small plastic cups numbered, and water. Other indicators include glucose and glucose strips and phenolphthalein. In all cases, it is important to test your simulation materials in advance. The key point of the do now is that the transmission of an infectious disease leaves behind a pattern of disease as it spreads. We get there by asking the students to consider what they would expect to see if a disease is contagious. This leads to the idea that as diseases spread, they leave a pattern of disease that can be used to map their spread in a population. The key point of the activity is that mapping the course of an infection can identify the source. We'll get there with an activity that simulates the spread of an infectious disease. The spread simulation activity begins by having students exchange a clear liquid with their classmates. After every exchange, students record their interactions on their worksheets, which they will later use to map the pattern of the outbreak and to identify the source of the infection. We begin with one infected sample, and the number of infected samples doubles after every exchange. Please note it is important to regulate the exchanges to avoid students exchanging only with subgroups. For example, exchange 1, move around the room, exchange 2, move around the room. After all exchanges are complete, use your indicator to reveal who is infected. Then complete the table with the class. You will then walk the students through the data to identify its origin. The first time you run through this lesson, this step can be difficult, so it is worth carefully reviewing the instructions in the teacher manual. The key point of the discussion is that vaccination disrupts transmission, protecting both vaccinated and unvaccinated people. We'll get there by having students discuss the impacts of vaccination and by calculating the spread of a model disease when half the population is vaccinated. We begin the discussion by having students consider what would happen if we ran the simulation again, but this time with half the class vaccinated. Students often have a misconception that vaccines only protect those vaccinated, and respond by saying that there would be half the number of infections. To discover the misconception for themselves, students complete the table in the worksheet to calculate the impacts of vaccination. After students have completed their calculation and shared them with the class, Use the PowerPoint slides to emphasize the impact of vaccination on the spread of an outbreak. The key points of the wrap-up are that there are several steps necessary to prove that a disease is caused by an infectious agent, and that Koch's postulates are the gold standard. In the wrap-up, we will consider how we could prove that a disease is caused by an infection. This is intended to introduce Koch's postulates, which will be the focus of the next few lessons. The key point of the lesson's homework is that Koch's postulates are the gold standard for proving that a disease is caused by an infectious agent. We'll get there by having students review Koch's postulates and explain whether typhoid fever, which we discussed in Lesson 2.1, fulfills each postulate. One of the most common misconceptions students have is thinking that vaccination only protects those vaccinated. Actually, one of the most important functions of vaccination is blocking the spread of infection to unvaccinated people, especially people who are unable to get vaccinated because of immune limitations like age, pregnancy, or disease. At the end of the lesson, collect the activity tables to assess students' ability to explain the effects of vaccination on the spread of disease. The challenges of identifying the cause of an infectious disease will be the focus of this unit. The impacts and mechanisms of vaccination will be further explored in Units 4 and 5. Don't forget, if you have any questions, concerns, or feedback, to let us know. You can contact any of the CTSE team members, and we'll be happy to help you.